Well, let's go ahead and kick it off. So I just wanted to say thank you everyone for joining us today. We are pleased to have Clément Cid, who's the co-founder and CEO of Mitico, and it's a point source carbon capture company within our portfolio. We're really excited about the company and just to explain a bit about why we invested. We believe that carbon capture is going to be and is a huge opportunity as we mitigate essentially the carbon emissions from the industrial revolution, if one wants to think of it that way. And there's a lot of opportunity to do that at the source of combustion or emission. And so Clément and team have developed a really interesting technology while they were at Caltech, and it's now obviously its own company now. And pairing up with just that technology and the market opportunity, another key reason why we invested was the team. Have been really impressed with Clément. He's just one of those founders that will do just about anything to succeed for his idea and for his company, and we've just been really impressed with the energy that he brings to this really important problem. So with that, so I'm, one of the managing partners here at Freeflow. So my name is David Fleck, and we've invested in about 32 companies now, that are scientific, deep tech companies that come out of, research institutes like Caltech. And I'm joined today by my partner, Kevin Barrett. So with that, we will pass it over to Clément to say to introduce his company and himself, and then Kevin and I will rejoin and ask some questions. So really looking forward to it, Clément.
Well, thank you, David. Thank you, everybody. It's a pleasure to be here. I remember watching some of those sessions and being truly inspired by the stories of other entrepreneurs getting something from typically a laboratory setting and then physically going out and forming the company and then getting the technology in a place where people can start using it and therefore making an impact. So it's truly an honor to be here, and I'm happy to give you all a little bit of about our story and what we're doing. First, I like to start, at the beginning where that idea started. It was at Caltech. As David mentioned, we started developing the core technology, the sorbent that goes inside the system, and I'll talk about it a little bit more in a few minutes. With Leopold here on the right-hand side of the screen, Alan in the middle, and myself. We became the three co-founders of Mitico when we started the company officially in August of 2022. But what we quickly realized is that we actually needed to get out and see where the technology can be applicable. Where can we have the best impact? The technology that Alan was started tinkering with was a carbonate-based sorbent to capture CO2 at a very low cost. And we quickly we're wondering, okay, are we going for direct air capture? Are we going for industrial emitters? Are we going for power plants? And so what it took us is going out, following, for instance, the NSF IPOR program and discussing with potential customers on where the technology could go. How could we tune the development to make it affordable, accessible, and a viable technology to reduce carbon emissions and also make money. So here is us in Central California at a power plant, looking at one of the back of the plant, and with Andy, he's the plant manager, discussing about where a capture technology would make sense. And that was part of the beginning of our journey. We founded Mitico, as I mentioned, joined Freeflow, SOSV, and also Caltech invested in the company last year. With the focus on really having a mitigation approach. So the idea is, anytime you do combustion, you are emitting carbon dioxide, unless you're combusting hydrogen. And these emissions of carbon dioxide participate to, literally gigatons of our emissions every year. So when we're looking at a platform technology like the one we developed, it is a little bit of a challenge. It's a little bit like the Forrest Gump box of chocolate. Where do you apply the technology? And so we saw that there was a tremendous opportunity for low concentration flue gases coming from electricity generation, as well as boilers, and other hard to decarbonize industries, such as electric arc furnaces, here in the bottom left of the screen. So going from that technology-centric to utilization-centric approach, we also looked at why people are not doing it. Why don't we have carbon capture everywhere today? Well, the reasons are, are obvious in a way. The systems that are currently available are complex to operate. You basically need to have a chemical plant and be able to operate that plant right next to whatever you're making. So you're emitting CO2 based on, the boilers that you're using in your industry or the power plant that you're operating. And now if you want to capture CO2 with the old technologies based on amine chemistry, you typically need to build a chemical plant and operate it right next to your site. The core components used in this chemistry, the amines, are dangerous. They require a lot of wastewater handling and treatment. So for very small emitters, it makes it even more complicated because now you have to handle a waste off-site potentially. And all of that makes it that it's very expensive. You have a system that now is going to have an impact on your plant, on your operating profits, that that basically makes it extremely hard, nearly impossible to actually operate. So with that in mind, we decided to work towards the best carbon capture process for point source emissions, so for post-combustion. The Mitico system uses traditional chemical engineering approach in terms of reactors. So what you see behind me is our Centennial system. It's our first large-scale prototype of the first generation of the product, designed to capture this one up to 100 tons per year of CO2. And it uses these columns that you see in the back, the A and B columns. These are fixed bed reactor systems. Basically, these are chemical engineering processes that are used for high flow rate, low pressure gas processing. And that's typically what comes out after a lot of combustion processes. And so in this case, we're basically turning this type of traditional chemical engineering into carbon capture machines. It makes it very low cost. The type of material is low grade steel, for instance. There is no high pressure, no high temperature. It's modular. At the small generation of the unit, you can have multiple reactors and increase the capacity linearly. It also scales up based on, these type of reactors, fixed bed reactor system. And so these are, readily designed and available for very large amounts of gas processing. So this way, the technology can scale up to be a viable approach for very large emitters, like power plants, for instance. And the process is non-toxic. So the sorbent that we use, that actually we do development here at our facility in Los Angeles, is only composed of earth-abundant, non-toxic materials. And this way, once it's spent, once it's been used multiple times in the system, there is no challenges in disposing or rejuvenating the sorbent. So now, when we move a step back from the technology and look at the customer, who is our customer? These are industries that are excellent at what they're producing, but do not know how to reduce their own carbon emissions. They have ESG requirements potentially. They have peer pressure. They have governmental pressure to reduce their carbon emissions. But when they look at their scope 1, what they are emitting themselves, really focusing on helping them with the reducing emissions at the source is our key motto. We look with them at a design approach on where the system is going to fit, and our technology has the huge advantage that we can basically be the last brick before the smoke goes to the smokestack, basically before the emissions evacuate. So they're already doing emission control. They're already doing, SOx and NOx removal, And we're basically an additional piece for CO2 removal from their emission. So how do we do that? You've seen a little bit the system behind me, and here is a short video about Centennial. We have it here in Los Angeles. We were starting operating it since last fall, and operating it under conditions that are relevant to our potential customers. It's operating under low CO2 concentration, typically as low as 3.5%, and all the way up to 10% CO2 concentration in the flue gas, which is typical for, gas turbines for the very low end, or boilers for the 10%, and other type of emitters within that range. Now, another part that is crucial is, what do you do once you capture the CO2? So we are integrating a tracking approach, software and hardware based, that basically follows the CO2 from the emitter all the way to the sequestration or the utilization. And why do we want to do that is because, we understand that we come as, the last approach in terms of carbon emission reduction, because if you are already aware of your emissions and need to reduce them, the first thing you're going to do is change the way you use your energy and reduce your own CO2 emissions this way, or part of them. But then you have still a lot of emissions coming from your own processes that that you're using for manufacturing. So the tracking part enabled the emitter to take full advantage of the fact that now they lowered their own emissions physically, and they can either provide carbon neutral products or file for tax incentives like the 45Q in the US, or avoid paying carbon taxation, because now indeed they've measurably and verifiably reduced their carbon emissions from the capture all the way to sequestration or novel utilization pathway. So we were talking about utilization, and that's one of the interesting part with CO2 is that we are we're emitting gigatons of CO2, but there is some markets that are still using CO2 for food and beverage, for greenhouses, for industrial applications, and obviously there is also enhanced oil recovery. As a company, what we are targeting is non-EOR use of CO2 that we see as a first step. Once the CO2 has been captured, there is an opportunity for the emitter to monetize their own CO2, either to use it on site if they are doing any process that use CO2, or to make it available to the local market. So here's a little bit about the system in its application. We got the flue gas coming from an emitter going through the column, and then we're using a slight temperature change to regenerate the column. This way, we basically have the CO2 and the moisture react, and then after it's been reacted, we get pure CO2 and water coming out of the column. And then once it's been regenerated, it can be used again for another cycle. So we basically have at minimum 2 reactor systems, 2 columns that are operating in the Centennial model. For the larger systems, we'll have at least an extra column to make sure that when we're doing the operation and maintenance for the technology, we're not impacting the industrial location. So going on the utilization versus sequestration, you might wonder, I was talking about utilization, I'm talking also about sequestration. And the way we look at it at Mitico is it's basically a push and pull from the CO2 demand or the emitter demand. What I mean here is for certain industry, we need CO2. There are potential to provide CO2 from local capture. We saw that, for instance, in the UK, where they had a CO2 shortage, and the government had to basically put back in operation a fertilizer plant to be able to produce enough CO2 for the usage in the country. That was a couple of summers ago, if my memory is correct. So when you look at the utilization scenario, there is opportunity for local utilization, and this leads to smaller capture amounts because that market is rather um, limited, just because the demand of CO2 is more or less finite. But when you're looking at it from an emitter perspective, the very large emitters like the power plants we were talking about, these ones require large handling of CO2 and most probably a sequestration strategy, whether it is geological sequestration or using CO2 in other chemicals that would indeed verify that it is not going back to the atmosphere. So this is more of a waste management approach for the very large systems. And so the way we are, targeting our go-to-market strategy at Mitico is really first addressing where the use cases are now. And as we scale up the engineering to very large systems, and displace the amine processes, in this case, the sequestration strategy will be there with tax advantages like the 45Q, for instance, in the US to compensate for it. So I was talking about the different sizes, and I forgot to mention, why we named that system Centennial. We have the Baldi system here on my left. That is our smaller unit that we use to validate the new sorbent technologies that we're developing here. We like mountains. And so after Centennial, the next iteration up in terms of scale will be Denali, and then Everest and Fuji. As we scale up the size of the system, there are engineering advantages to that. And so this way, the CapEx per ton is reduced even further. As of today, what we are achieving with the new generation sorbent and the system that is going into piloting in Canada is a cost per ton, total cost over 10 years of ownership of the unit, and with Los Angeles energy prices of around $120 per ton. That's the anticipated cost for the pilot, the first pilot. And as we scale up the engineering, and we have new sorbent manufacturing methods and morphologies, we can reduce that cost further. And we anticipate a cost lower than $50 per ton for capture when we are at scale. We actually just submitted a proposal to the DOE regarding that aspect of two enabling technologies that will reduce that cost. One aspect that I didn't mention that is a crucial key advantage of the Mitico process is our low heat of regeneration. So basically, when we compare ourselves to the amine process, for instance, we are about half the energy need to desorb the CO2 from the sorbent. And this is the core energy cost in any carbon capture technology, is how you get the CO2 out of the system. In our case, we are using basically taking advantage of a chemical reaction that is at the same temperature as the amine process, but at a lower overall energy requirement. And so that makes it extremely OPEX-friendly technology compared to others. Now, I was mentioning our pilot coming this summer, and I just wanted to give you some information on that. There will be a public release coming in a few weeks, so keep your eyes peeled, as we say. We are partnering with 10 industry participants and 2 government agencies for a field validation of the Mitico technology. The field validation will be at CanMet Energy in Ottawa. And this is a platform laboratory where we can validate the technology under different conditions, different type of emissions. We're looking for interested emitters who would like to participate in the testing with us. There are multiple ways they can be involved. And so if you or people who are interested in this novel technology for emission reduction and would like to get first mover advantage, please don't hesitate and send me an email. We can discuss further about the modalities. I can tell you more about what the testing will be. But this is really a great opportunity for you or people who operate industries that can basically have our process be used in certain conditions that are very relevant to their applications. I touched a little bit about the different size and the different approaches. So when we look at the small system, the centennial approach, we are looking at a product-based approach in our case. So what we want is to empower the emitter to take care, basically to see that lowering their emissions is something that is feasible, that is inexpensive, but also they can turn that CO2 into a profit. Cost per ton of CO2 is variable depending on the geography. In the US, it can be between $250 to $400 a ton, depending on the grade, depending on the location. And so there is opportunities there basically to turn a cost center into now a revenue generating process in the company. For the larger system, Denali, Everest, and larger, what we anticipate is a project-based approach. These will be larger footprint units, and the project will own the CO2, and Mitico will participate in the project in terms of consulting and engineering services, as well as IP licensing fee and some share of the revenues of the CO2. When we look at emissions, we can easily get overwhelmed by how much CO2 is going into the atmosphere each year. But with a technology like the one we developed, is really looking at it into, okay, how can we do something about it, and where is the advantage of doing carbon capture at the source? And there's a tremendous opportunity for revenue generating because of first governmental help, but also ESG pressure on companies, as well as opportunities for that CO2 local utilization. So what we foresee as a company is, lowering emissions at the source for many industries is a necessity. Is something that is much cheaper than changing the way they make things, and is something that can address a lot of emissions, like gigatons of emissions all across the globe. With that, you might also be wondering why Mitico, why not others? We're not the only ones going after that market. Obviously, this is a tremendous opportunity. As I mentioned, there's a lot of CO2 to be captured, and at a cost that is very low. But we think we are the best one positioned because of the type of sorbent. So the core that goes inside the unit is easy to make. You can make these carbonates are available anywhere in the world. We can get processes that are already at scale to make the sorbent. We work with a couple of industrial partners in that sense. We also have the chemical engineering that is already at scale because we took a type of process that already exists and is in multiple scale and adapted to carbon capture. And so all of that makes it that we are extremely well positioned to basically provide a solution to carbon emission and doing it at a extremely low cost. With that, I started with the co-founders. I like to end also with the co-founders and the rest of the advisory board. We're lucky coming from Caltech to have been given the opportunity to work on this technology in the laboratories, both with Professor Hoffman and Professor Hunt. As we spun off the company, we got support from Caltech and then Freeflow, as well as SOSV Hacks, who brought in advice and also money. You cannot, do anything without both. And so we also have advisors coming from different backgrounds who helped me and the rest of the team take the technology from a laboratory process, a laboratory invention, into something that is now being piloted at TRL6 and then being commercialized next year as a first standalone carbon capture system for point source emitters. With that, I'd like to thank everybody. And I also, wanted to tell that there is an opportunity for investment. We currently are raising $3.5 million in a seed round. So if you are interested in joining, our investors and helping our technology go to market faster, please don't hesitate to reach out. my email address is here, and I'll be here until I think the end of the hour if you have any questions. Thank you.
Thank you, Clément. And one thing I'll say is just to the audience, as we start to ask some questions here of Clément, feel free to put any questions that you may have into the chat feature, and we'll get to as many of those questions as we can, but we definitely encourage audience participation here. But the first question that I wanted to ask Clément, and it goes back to the team a bit, is, you know, I always love to hear and better understand, you know, you're a scientist, right? And did you get into science? Did you get into this because you knew you wanted to create a point source carbon capture company? Or, you know, what was your journey and the team's journey to get to the point where you said, you know what, I want to translate this out into a company? And yeah, just walk us through that evolution.
Yeah, thank you for the question. Well, first, I got into science because I like to teach. So I was not born an engineer or a scientist, but wanted to be a teacher very early on. And my path just made it that at some point I ended up at Caltech. And I worked for about 10 years on the Reinvent the Toilet challenge. So I invite I invite viewers to Google Caltech toilet, and you'll see me a little younger, but still without that much hair, on these wastewater treatment technologies. But what I realized is you know any type of environmental technologies, or most of the environmental technologies, require a fair bit of energy. And if you want to solve environmental crisis in general, you need to have readily available electricity. And it's not to paraphrase Bill Gates or other people that thought about it before me, but it is really a necessity. And the best way, or I think the most affordable and lowest environmental impact to generate usable energy is to use fossil fuel with carbon capture as of today. As we move on to a more renewable future, then there is other alternatives that are widely available. But what I saw is in a lot of developing countries that there is still a need for fossil-based energy. And if we do not provide mitigation solutions, then we're basically trying to solve a problem in one side of the world, but increasing emissions in the other. So it's kind of like the whack-a-mole situation. And so that's really what brought us to thinking about where we're going to use the technology. We were wondering, should we go towards more direct air capture approach or point source? And really our thermodynamics, one class told us that point source is key if you want increased efficiency, but also Clean Air Act applies to point source emitters. Any type of regulation is easier to be applied to point source emitters. And so really for us, we see that as the best way to reduce overall carbon emissions in the world.
Gotcha. And then you touched upon the I think it's important to touch upon the recent EPA announcement, which some of the viewers may or may not be aware of, but that started to mandate the capture of CO2 from gas and coal plants. Can you just walk us through, what that was and the potential impact on your company and the opportunity in front of you based on that news?
Yeah. So a couple of things. I don't speak on behalf of the EPA, and I'm not a federal government employee. So what I'm saying is only involving me and myself. But these regulations for fossil-based electricity generation apply for coal and gas-fired power plants. We've recently actually also got news from the U.S. The IEA, the Energy Agency, that U.S. emission for electricity generation have been decreasing because coal based electricity generation has been decreasing. So both the EPA regulation that has been issued and what people are doing show that coal is phasing out. if now coal is still running, there are actually requirements even for sites that are already existing to do carbon capture and limit the emissions above a certain amount based on the age of the plant. It will be a different percent reduction required. Now, where we come in and where it is extremely beneficial to already think about carbon capture when there are new power projects is that gas-fired power plants, which are actually increasing in terms of the number being deployed because of all the extra energy usage that we have, or electricity usage that we have from data centers, from basically electrification of transportation, etc. So these gas-fired power plants are also under the regulation, and the ones that are being built or that are going to be built very soon will need to do carbon capture and will need to limit their emissions. We can be the solution to the problem because at scale we're much cheaper than the amine process, easier, and also it is an opportunity for both having the flexibility of using natural gas. Some companies even call it their flex generation, when they talk about their power plants, and using natural gas, keeping that flexibility while avoiding most of the carbon emissions. So it's basically taking a win-win situation in places where you have still difficulties to put renewables for the entire grid, which is for now, like the entire US, for instance.
Yeah, gotcha. Thank you.
So Clément, maybe just on this point, you could just unpack this a little bit more and expand, beyond the United States and maybe to Canada, to Europe, other markets with which you're familiar, in terms of what appears to be, an inevitable shift from voluntary initiatives, ESG, peer pressure, some of the things that you mentioned earlier, to required, regulatory or legislative requirements that goes beyond the EPA, which may be subject to certain, political dynamics in the near term, but longer term, how do you see this sort of playing out on a global basis? As this is truly a global technology, and your market is a global market.
Yeah, that's an excellent question, Kevin, and I'm just going to give you a little bit of background from the U.S. perspective. I was at the EarthX conference last week, which is organized in Dallas, Texas, bringing both sides of the aisle in the very polarized U.S. environment about the climate issue. And what we see is both agree that carbon capture is something that can be done and should be done as long as it doesn't have a negative impact on the industry that the carbon is captured from. So as long as you can do it for cheap, everybody agrees that it should be done. Now, that is very positive point because it shows that there is willingness. Texas is actually positioning themselves as a key center for carbon capture in the US, Houston in particular. So we see the US as, there is peer pressure from companies wanting to buy from other companies carbon neutral products. There's peer pressure from investors making sure that the companies they invest in are following their ESG. And there is also some pressure, as we saw with the EPA, from the government. Now, other countries are working a little differently. We have two examples that we like to cite because these are, we think, key markets for our technology and key deployment. And I'm also going to answer in this way the question that Frederick had regarding waste to energy plants, because one of the application of the Mitico process is really what we see as something critical is the waste to energy that is in Europe, and where a lot of the municipal waste is being incinerated and a lot of CO2 is being emitted. So Europe in general, including, if we want to include the UK and Switzerland, so Europe as a continent is pushing for a lot of carbon regulation and lowering emission thresholds from many industries, including municipal waste management. And so these are opportunities for us to enter markets that have a little bit of a kick for emitters to effectively reduce their emission. And when they're facing different options, typically, waste to energy applications will need carbon capture. You have biomass combustion also. If you're looking at renewable ways of generating electricity or heat from sustainable biomass, you can also add carbon capture to that process. And this way, you're effectively doing negative emissions. So you're basically taking some CO2 out of the atmosphere. So this is an applicability of the technology that we're looking at when we will be piloting in Canada. Canada has also a carbon tax that applies to emitters, even as small as 10 to 50,000 ton a year, depending on the province and depending on the industry. And what we're enabling for them is a solution to be lower than the baseline allowance that they have, and start, the process of reducing their emission effectively, and not just stand there or pay the tax until they either have to disappear or until the capex is so large that they end up moving the industry to other places that do not have those regulations. So we think that mass mitigation of carbon emission is a way to keep jobs local, to enable industries to reduce their carbon footprint without having a detrimental impact on their balance sheet, and start transitioning towards a greener future.
That's helpful. And maybe just a corollary issue is that early efforts around carbon capture were centered largely on carbon credits, and I think that's that's a sort of a system or its own ecosystem that has confused a lot of people, hasn't been particularly precise or easily measured. And so maybe you could just draw, what to me is the sort of distinctions and the sort of stark contrast between what you're doing, which is measurable, quantifiable, verifiable, reportable, versus the old carbon credit economy.
Yeah, that's when you look at carbon credits, it's all about how the measurement is done, as you rightly touched, and in the past, the methodologies were, there's been issues that people, mistakes, and some of them were, cases that were particular to specific cases and kind of had an impact on the entire ecosystem. So I don't want to be, blaming everybody, but it is harder to count a number of trees than it is on a large scale than it is to count a number of tanks that have been filled with CO2, and then CO2 that has been sequestered in one particular place using geological sequestration. So what we see for us is it's a little bit all on board type of situation where you need all of that. You need natural based solutions that can be monetized as carbon credits. Some of them are very high level and easier to monitor than others. And so that's where there is, I think, an opportunity still there. But in our case, what we're looking at is really an engineered system with ways that are, certifiable to monitor the transport of CO2, and then the sequestration or the utilization into products that will not emit CO2, or that will be considered, non-sequestered CO2 type of products, such as sustainable aviation fuel, for instance. And I think part of that answering Jane questions about the protection of the technology, since we're talking a little bit about the technology side, although we can clearly verify where and how the CO2 is being captured, there is still room for improvement in the entire value chain, and that's why we are adding the tracking component, because we want to make sure that there is not a loss of CO2, quote unquote, in the transportation or in the sequestration. Now, where our IP comes very strong is in the process that we're using, so not on the type of reactors, but how they're being used. we make modifications inside, so that's part of the patents that we submitted that are under review, and also the sorbent that goes inside. So a key is really enabling that chemistry, potassium carbonate chemistry, in a gas solid interface under a wet environment without having the component turn into mush. So if I tell you, okay, we're using potassium carbonate, you go and use it, you'll see that you cannot reuse it multiple times unless you have it in liquid. In our case, we have components that we add with the potassium carbonate to stabilize it, and that's under our both protected under patent applications as well as some trade secrets.
Got it. David, we've got a lot of questions piling up here, so I'm going to hand it back over to you.
Yeah, sure. Well, let's just start taking them in sequential order. So, someone asked if we would invest in the seed round, and maybe just to provide context for how we operate, we come in at the pre-seed or seed, depending on the stage of the company. In this instance, it was the what we would call the pre-seed. So, and we're generally supportive of our companies that are knocking the cover off the ball, like Mitico. So yeah, we were excited to continue to support this company. Another attendee asked how you have learned to be a founder and CEO, and perhaps anything you've learned from us as well. But yeah, just curious about that process maybe and that evolution for you.
Yeah, that's a good question. So I was not an entrepreneur. When I was working at Caltech, I was actually working with startups in taking the technologies, the wastewater treatment technologies out of the lab. We had projects on that reinvented toilet, but also on pathogen detection. And I was looking at both the pathogen detection and the carbon capture system and seeing kind of where could my impact be the most useful. And I'm not a biologist, so I was very good at project management on that project. We had a lot of pressure coming from COVID-19 and making a system accessible for pathogen detection in wastewater. We piloted it in 3 different places, including South Africa during the pandemic. So that was all fun, and there was a huge opportunity for that product to come out. But none of the researchers involved in the project was interested in taking it into a company. And so, because I'm not a microbiologist, I felt like it would have been harder to talk about the technology and understand it to the point where I would be able to sell it. So I think that aspect is very important, like knowing the technology and then being able to talk about it and being able to understand the market. What I liked with carbon capture is that there are a lot of pieces in the puzzle, which makes it, for a Caltech brain, I guess, it's very interesting because it's a nonlinear type of problem, multidimensional. You press something and it might have a butterfly effect on like very far in the ecosystem. And I think understanding that through Freeflow, figuring out how we can talk about what we're doing, having these type of webinars, being part and being encouraged to be part on multiple accelerators. If you are interested in carbon capture, you have a cool technology, or carbon utilization, or anything to do with carbon, I highly encourage you to apply for the Carbon to Value initiative, which looks at the entire puzzle. And so having these type of accelerators, having support from investors, whether it is SOSV Hacks, Freeflow, or Caltech, through the Office of Technology Transfer and Corporate Partnerships, has really helped me and is still helping me take the technology into a product and making it available to industrial emitters.
Thank you. There's a couple of questions that I think get to a kind of a similar point. Just how does this scale? And then which technical aspects need to be improved to prepare it for that climb up those various mountains that you outlined. Yeah, and I'd be curious, I know we talked about this before, but just if you can give directionally guidance on where you think the cost per ton can get to within some sort of, intermediate term timeline, that'd be helpful.
Yeah, and I'll do it with one order of magnitude.
Yeah.
A standard deviation of 20%. Uh, so I'll talk about the technology. One of the key advantages we can actually in our processes, we have it at a small scale and already at a very low cost. So what I was mentioning is the system that you see behind me, Centennial, its bigger brother, going to Canada this summer, is designed for a capacity up to 1,000 ton CO2 captured per year at an overall cost based on the sorbent that we have now developed of around $120 per ton. So this is, total cost of ownership per ton. So this is higher than the 45Q tax credit, but this is much lower than the cost at which you can sell the CO2 to the local market. So that's where there is the interest. As we also continue the development of the sorbent, we can basically lower the overall cost per ton, having a sorbent that works for a longer period of time, that can capture more CO2, etc., and faster. And then there is also the CapEx scale up. So that goes into that question on, what does it take to scale it up? When you were looking at small modular system, we already have a manufacturer that can make multiple units like that at quite a low cost. We are looking at, manufacturing in the US for this particular technology and in the local markets where we'll go. So we're part of an accelerator called Scale for Climate Tech for that purpose. For the very large systems, then it is working with EPC firms, so engineering, procurement, and consulting firm like Fluor, for instance, or Technip, to just give a few names. And so these are, key partners in scaling up the very large units and adapting them to the plants. So adapting them to the process or to the gas-fired power plant and taking most of their flue gas or all their flue gas going through these type of large system. The small system is only 12 square meter. So this is relatively small footprint. It comes in 2 small shipping containers. The columns that are right now sized for the test in Canada will be between 2 and 4 meters. So why that range? Because we are working on gas diffusers. If we do an excellent job, it will be 2 meter. If the job is not as good, it will be a bit more than 2 meter to ensure that the chemical reaction can happen. So we're already at the scale ready for commercial pilot deployment with the small technology at a low cost. And we are going to productize that one and start entering the market, as I said, in 2025 with, first units going into a project. And as we continue that, learn from these deployments, keep scaling up for very large point source emitters.
So with point source, I mean, so where do you think over the next 7 years or so, you think the cost per ton can get to?
Much below $50 per ton. What we anticipate is between $30 and $50 per ton. With, sorbent performance that we observe now, then scale up, assumptions that are based on the type of reactors that we're doing. So it's not just our magical wand and saying, oh, we're going to have, divide everything by pi. But it is actually, this is the type of technology, type of reactor systems, working with engineering firms about what that scale up would cost and what the unit would look like. Does that make sense? Does it not make sense based on what we already measured? And the same as I was telling you about the energy costs, these are based on, measurements. We still keep our Caltech hat when we're doing the science and engineering. So it's all, triplicates and careful about making assumptions. And so in terms of the overall cost, it's really a conservative approach in looking at, based on solvent performance and then what is required in the chemical engineering part.
Yeah.
Now, one thing to keep in mind is for very large systems, a lot of the CapEx is also dependent on the installation and what, especially in brownfield sites, so retrofitting. So that's why the spread between 30 to 50 because in some sites, the capex will be more important because the site needs some changes that are consequential, and in others it might be a little, relatively speaking, modification.
And Clément, I think it probably bears repeating or just reinforcing the, an important point from one of the slides you showed, which is that as you move to these higher capacity and higher volume systems, you shift the OpEx burden over to the partner or to the customer, and you move to a licensing model where you collect licensing revenue, consulting, other revenues, but you're shifting the OpEx. And that's something that we're seeing at Freeflow. We're invested in 3 different non-competing carbon capture technologies because we think the demand for carbon capture is essentially infinite. And to the Caltech crowd who like to calculate these things, I'm not sure how you go about calculating that, but this is a tall hill to climb to actually get to net zero. So maybe just to reinforce that you're going to shift that CapEx over to your partners and to your customers, and it's not something you're going to try to finance yourself as you scale to these much higher capacity systems.
So that's a very good point, and it is not exactly a shift to the partner for the capex. So the OpEx is obviously.
I'm sorry. I meant the OpEx.
Yeah. So for the OpEx, yes, it is. I mean, the operation cost of the technology happens with the partner. So whether it is the small scale or the large scale, and what we estimate for the large scale unit is only a few percent, basically inefficiencies to the plant. So this is something that we'll start validating this summer in Canada with the small scale system. But look at what's the impact. Keeping our system boundary, what's the impact to what it is connected? Because that's one of the key challenge also of the amine process. It sucks a lot of energy, and it also has a detrimental impact on the turbine, for instance. So the OpEx part is taken by the user of the technology. The CapEx part is financed using project finance for the large system. So what we are looking at here, and there is a lot of opportunities, the same way was in solar couple of decades ago, where the technology was maturing and the market was maturing hand in hand. I see a similar approach here with carbon capture technologies, where we are proving that the lifetime of the technology can be multiple decades, that it is a revenue generating opportunity because we got need to reduce our carbon emissions. And the way to do it the cheapest is using capture and sequestration or utilization. So whether it is through government credits or, tax credits, incentives, or avoiding taxation on carbon emissions. And so the way these can be financed is through traditional project finance, where how the unit is going to operate, the OpEx associated with it. You have a project that can handle the CO2 that has been captured for sequestration or utilization, and now you basically have something that generates that captures the CO2 and generates the revenue associated with it. So that's the way we see it. For the small system, we're looking at opportunities to partner with financial institutions for the emitters to compensate, to avoid them paying for the capex, because even though these are much smaller in capex cost, some of the markets we're targeting are sensitive to it, but there are opportunities. We've seen other companies work in that field for small emitters, and there's financial returns based on the cost of CO2 for current usage that is very attractive to some of these financiers.
Right.
And I beg to also put a positive spin on the tall mountain to climb. Sometimes it's kind of, we can be overwhelmed with the amount of CO2 that's being emitted, but what we have to think about is, and as we see it, the same with insurance companies, it's easier and much cheaper to prevent. And that's where, we can we can generate revenue, because prevention will get us to a point where we can keep our standards of living and avoid dramatic catastrophes. And so what we're looking at is an opportunity to basically be at the forefront of the prevention. You know, climate prevention, I think, is a term that is not really used. But in our case, is really that mitigation of carbon emissions is preventing for the worst, and making sure that we have a fair environment for next generations, but also other countries are still able to grow. And going back to my sanitation aspect, where I still care deeply about low middle income countries and how people get access to basic needs, what we take for granted, like sanitation. I think low cost, decarbonized energy and available 24/7 is still a necessity for many people. Decarbonizing that is crucial.
Yeah. I don't know about the others on this webinar, but just in hearing you talk, it can be a bit overwhelming sometimes to think about the problems that are in front of us. But I take solace in the fact that there are people like you and your team that are addressing, these really important problems. But technologies that, as you said, can get to like the $30 to $50 per ton in the not too distant future, which would be extremely impactful, as that technology starts to be unleashed into the world. So either way, thank you for that work. Any other final thoughts or comments before we adjourn? We have a couple more minutes.
I just wanted to thank everybody for the opportunity, and I'm available if there are more questions. I invite people to check out our website, mitico.tech. If you are in the Los Angeles area, don't hesitate to reach out. Also, we give tours, and I can tell you more in a few weeks about our project in Canada, and there will be opportunities also to seeing the technology over there. So thank you, everybody.
Thank you. I just put the website into the chat if people are interested in checking it out some more. And there's contact information there too, if anyone wants to reach out to Clément directly. So with that, I think we can conclude this webinar. So thank you, Clément, for joining us today. Thank you, Kevin, as well. And thanks everyone for your attendance.
Thank you. Merci.
Thanks, everybody. Thanks, Clément.
Take care.
Bye.